Java meets AI. How to build LLM-powered applications with LangChain4j. Presented by Lize Raes.
Hello, everybody. Welcome again. I'm happy you're all back for another talk, this time on LangChain4j only. Let me present you the LangChain4j team. So Dmytro Limarski is the one that created the library and is still its lead developer. And by now we have plenty of contributors on GitHub, also people from Google, from Microsoft. So it's really nice to see our library grow so big. And what LangChain4j does is it allows you to easily connect and interact with LLMs originally, large language models. And now we also support other types of models, not only language models. So where does it come from? There's the library LangChain. It's super popular. Who of you has already used the original LangChain library? Good, that's a few people. It's an awesome library. It allows you to make agents, to call tools, to chain models. It has only one big flaw, and it's for Python. So that's why we made this in Java. And the way we consider this is that we make it easy to talk to this zoo of models that's out there, like either the most famous one, commercial ones, local ones, or also like models that you will fine-tune yourself. There's all ways of really easily plugging that into LangChain4j. And so we see these models as part of our infrastructure, rather than that we're gonna build them ourselves. A number of concepts here. I guess you've already heard quite a bit of things about neural networks and AI. So just to make sure that we're on the same page in kind of terminology, the language model is what we call the generative completion model that will just output, that will continue your phrase. A chat model is a language model that is fine-tuned to want to chat with you. So it behaves quite a bit different. And then there's embedding models. That's a whole other type of beast. This will turn the meaning of your phrase or of your text into a vector that represents this meaning. So a numerical representation of meaning. That's very interesting, because we can then store all the meanings of our text fragments into an embedding store. And that's very interesting to later search things with a similar meaning. So for example, you can use it to categorize. You would categorize clothing website texts. You would embed them, make every clothing description into a vector, store it in your embedding store. And then, for example, you could embed just the word red and see which clothes it comes up with. And it will probably be those clothes that are red. So any type of categorization is really easy with these embedding stores. And also, if you want to know which segments can answer your questions, you can also embed your question and search the most similar, semantically similar pieces of text and get them out of there. So with LangChain4j, we make talking to these models a piece of cake. These are the components that are in LangChain4j. So on your left down, you have the basic blocks, which are, of course, the language models. But now we also support image models, and then more modalities are coming soon. We have prompt templates, so you don't have to describe in long what you want the model to do. You can use parts that you say, I want to reuse this, and I just want to plug parameters in there. You have output parsers that take care of this text output of the model. If you were here this morning in my keynote, you've already seen a bit how they work. So we get Java objects out of LLMs. Of course, they don't return real Java objects. They return JSON that we will parse afterwards. And LangChain4j takes care of you for that. Then we have the memory building block, because models don't come with memory themselves. We have to take care of that, and we make it really easy for you. And then there's tools that the models can use. On the left side, you see RAG. RAG stands for Retrieval Augmented Generation. It's a complicated term to just say, interact with your documents. So retrieve the parts of your documents that make sense. So we have a couple of blocks that we can use for that. And then on top, we have the interface that comes over it. So we have chains, like in LangChain, where we can chain different of these basic blocks together, and AI services, which are even more powerful and flexible. This is the list of integrations we currently support. So as you can see, there's OpenAI in there, there's Amazon Bedrock, there's Google Gemini, there's Mistral now too. So we have all these commercial model providers in there, the biggest ones. If ever you want to use something that's not in there, we gladly invite you to make your own contribution. It's interfaces, so you can have a look how it's done for the other ones and just make a pull request. We also support a couple of special ones. HuggingFace, for example, that's ecosystem and a website that offers a lot of open source models, if not all of them. And that offers you the infrastructure to train them. They have data sets, they have guides on how to do it. And once you have it running there, you can easily plug it into LangChain4j and use it from Java. And then there's things like Ollama and local AI, which provide a kind of clean API resembling the one of OpenAI with GPT. And you can run any local model on your local machine or on your local servers behind it, and then also really easily talk to it. For image models, we have DALL-E, Google's Gemini, and then also via Ollama. Again, if you have local open source image models running, then you can go via Ollama and also integrate them in your Java application. This one, I'm not going to go into detail, but there's now a zoo of embedding stores out there. So that's kind of databases that are optimized to store these long vectors that encode our meaning, and that are optimized to search similar vectors really fast. Document loaders, that's because we often want to interact with our document. We want to have kind of a knowledge base behind our application, and that's where we have to split all these documents in parts and then store their meaning in our embedding store. So we support the main type of documents, also GitHub, for example, if you want to interact with your code. Then we have code execution engines. We'll come back to that later, where we use those. And then we integrate with Quarkus and with Spring Boot, too. So let's give you a first quick demo. If you were there this morning, you have already seen it. It's a Spring Boot example this time of a customer support application. And it can use tools to go check in your database if there is a booking, if it can cancel the booking, and more actions. You will find all these examples on our GitHub repo. At the end, I will share the links so you can find them. Then you can play around at home yourself. So we've just made a kind of dummy database. It's not a real database behind it, but it could work. And then it knows our terms of use. And when we run this, we will be able to talk to it as if we had a real chat assistant. If it wants today. Yes, there we go. Hi, I'm Lisa. I want to cancel my booking. It's not very original, right? I've put here the output on visible, so you can see a bit what's actually sent to the model in the back. And that's what LangChain4j takes care of for you. So you don't have to deal with wrapping this and obeying what the API asks you to get there. So what it says back is now, hello, hi Lisa, I can help you with canceling your booking. Could you please provide me with your booking number, customer name, and surname? So the number is 123. Sorry. Yeah. And now I don't give all my information. And what you should now see . Wait, so it asks me for my full name and surname. It's Lize Raes. Now we set up the database that I'm not in there with this booking number. So, sorry. what we would see behind the screens is that it's gonna call a tool, and it's gonna get back. So here it's calling our tool get booking details with my surname, name, and booking number, and it will get back booking not found, and from there it can deduct itself. Okay, sorry, I booked in the name of Klaus Heisler. Let's see if it can handle that. And then it should be able to retrieve our booking, but then run into the other error that it's actually not allowed. So here it's calling again to get my booking, and then, yeah, okay, it forgot that it's, how can I assist you with canceling this booking? Well, cancel it. It's maybe not perfect yet, right? Right, and now it says that it cannot because we gave it got a booking cannot be cancelled exception, and then we also passed it some pieces of our terms of use. So then it makes out of all this information, it figures it out itself, that it will tell me why it can't cancel it. Good, but let's take it from the basics. So I would like to start with the Hello JFocus program, so that you know how it's done and that at home you can just make them too. We have in our examples a tutorial folder where all these tutorials are found. So I find it so easy to just connect to a large language model in Java and get something out of it that I will live code it. I'm always very much advised to not do that. So let's see if it works today. We will want a chat language model because we want to chat. We call it model, and we take an OpenAI chat model, and with API key, which I stored in API keys. By the way, if you want to try this at home, instead of getting it from this file, you can just put the string demo there to test it out. We have a certain quota where you can just play around with it so that you don't even have to get your OpenAI key. That should be it. And then we will want an answer, and that would be model.generate hello JFocus. And then let's print that. Now I have to think of this talk of this morning, like why? No, system.out. I would be fan of a print command, a simple one. Good. Let's run this. So we're sending now hello JFocus to the model. Let's see what it answers. Hello, how can I assist you today? Now imagine we want to actually make it say hello JFocus, which would be more in the sense of the hello world. We could try this. Say hello JFocus. See what it does with that. Not bad. Not bad. It has an exclamation mark, though, that we didn't ask for. And this is like a small thing. If you run this a couple of times, you will get anything back from hello JFocus, how can I assist you today, to the clean hello JFocus without an exclamation mark. So it's pretty random. There's some randomness in these models. And that's maybe important. One does not simply get hello JFocus out of an LLM, to say it with Boromir's words. It has important implications for business applications, right? That you're not building on something deterministic that you can count on always. Good. I'm not going to run all the examples here, but I'm going to tell you which ones are in here so you know, but if you're interested in something specific. Second example lets you set the model parameters. So it depends on which provider and model you're using, but we always support this builder format where you can set all these parameters. Interestingly, log requests and log responses. Then they will appear on the console, and you will know what has actually been sent back and forth if you're unsure. This is an example where we use an image model. I'll already run it because it takes a bit longer to generate an image. But now I explain you. It's very similar, but this time with an image model. We took DALL-E 3. We set our key again. And then we asked it this. Swiss software developers with cheese fondue, a parrot, and a cup of coffee. So the way we've set this up by default is that it will generate you a link. But of course, you can override and implement this your own way when you use LangChain4j. Let's have a look. It's not bad, and yeah, I like how it's inclusive. Then prompt templates, that's where you will want to look if the moment you end up with your program where you're telling your model, behave like this and fix this, and you can also use this, but still behave like this, then you know you will be needing prompt templates where you can just set, oh yeah, this system message, this what we always give is fixed, and we just plug in a couple of parameter strings to deal with it better. So you have a lot of examples in here. And then what's a really fancy feature, of course, is streaming. Because if you call a large language model and you just have to wait for it to answer, at the moment there's quite some latency. When it gives you 1-2 pages back, you can easily wait for 20 seconds. It's super boring. Whereas when you can just read word by word, it's super fascinating. So it looks a little bit different then. We will need an OpenAI streaming chat model. And then what we have is, when we call it, instead of just generate from your prompt, from the string that you input, you will also need to define a streaming response handler, where you set what happens on next. So on next, we're just going to print every token, and then on complete and on error. Now, what is a token? A token, it depends a bit from model to model what exactly is a token, but it's usually around 3 characters that are interpreted together by the model. We have a token counter on our models in LangChain4j. So if you want to be sure that you're not sending too much, or if you want to have an idea of how much it's going to cost you also, then you can use this estimate token count methods. So I ask it this prompt. Write a short, funny poem about developers and null pointers, 10 lines maximum. And I'm going to print the number of characters in there and the number of tokens calculated with this token estimator. And then we're going to let it write this, and it should stream it nicely. I already know that it will not listen very well to my 10 lines command. It's really hard to steer sometimes, so I give it some more space. So we have 77 characters and 23 tokens for that. And what it outputs for us here in streaming mode is, in the realm of code where developers dwell, lies a fiendish beast we know too well. Null pointer, the trickster, causing strife with a single line, it ruins our life. Yes. Oh, developers brave, we curse and swear as we debug, pulling out our hair. Null pointer, you sly, elusive sprite, always lurking, ready for a fight. But fear not, dear coders, we'll persevere. With wit and coffee, we'll conquer our fear. For in this endless battle, we'll prevail, and null pointers, beware, you shall fail. Let's hope so. Yeah. So the model we're uploading for is GPT 3.5 Turbo. And I usually put in my next slide, which is like, it's very unfunny, but I'm going to skip it this time because it was actually quite funny. Some tips from the LangChain4j team. One thing is knowing how to code and knowing how to chain these LLMs. Another thing is to get out of it what you really want, which is a bit harder. Therefore, you have leaderboards. I will share some link at the end that compare all types of models on all kinds of tasks. So for your application, best to choose the best one you have available or that's affordable to you, because it makes things much simpler when the model actually listens to you and is more steerable. There's this demo key if you want to play around with the library already like that. And it's important to choose good prompt templates. So there's this concept of prompt engineering, which is making what you send into this model as good as possible so the model actually listens. It's an art in itself. It would be a talk in itself. But things like answer strictly in the following format, or give 5 options, or 10 lines maximum, those are really useful. You'll figure out very fast why. Otherwise, you get these three pages of text that you really didn't ask for. All right, let's go to chatting. So it's important to know that a model is stateless. So every time we call GPT or any other model, it doesn't know what has happened before in the conversation. But all chat language models provide some way of telling it what conversation we already had. Typically, we have a system message that always applies. Like, you are talking to a toddler, explain it on toddler level, something like that. It applies for your whole conversation. And then you have user message, which would be the human that asks something. And AI message is the answer we got from the model. And we can give these things along. So if we already had this conversation, we are at user message 3. We have asked our 3rd question, follow-up question. We already had these 2 answers. We're going to wrap that all in kind of memory object, send it along to the model, and it will then know how to answer on the 3rd question, remembering everything that has been said before. And we made it really easy for you in LangChain4j. So again, we have a streaming chat model here. And then we will be wanting to have a chat memory here. There's a number of ways to do this memory, because models have a limited context window. It depends a bit on the model, but you can put endless chat in there. It's going to be too big, it's going to get chunked off. And it's costly to send more in there than you need, because you also pay for your input characters. So we will want to chop off that memory at a certain point in a certain way. And a token window chat memory with maximum 1,000 tokens is like a really easy, dumb way to do this. You just like 1,000 tokens maximum, the rest we cut off. There's, of course, other ways where you could say, summarize what has been said before, or other smart techniques. You can implement these yourself, because this chat memory is an interface. And then we have a system message to set, and then we can just add the system message to our chat memory, and then we can set user messages, and then we will add the AI messages when we got the answer to the memory in order to ask follow-up questions. So you can try this example out at home. The one I would like to show you is also one that uses memory. Then you see how it works. But it kind of abuses memory. There's a really nice way to abuse memory to make language models do what you want. It's called a few-shot technique, where you pretend you had a conversation already, even if you didn't, where you asked your questions and you pretend the model answered a certain way. And then, if you ask it another question, it will very well follow how it was set to behave before. So I made an example here where I wanted an answer to feedback. Imagine you have a product, you want feedback from your users, and I wanted, if the feedback is bad, I want a ticket to be opened with a summary, and I want it to apologize. If the feedback was good, I want the positive feedback to be stored in our positive feedback database, and a thank you from the model. And I want this positive feedback to be stored because I think we developers also merit some positive feedback from time to time. So I made a fake history, and I added a user message that said, I love the new update, it's very user-friendly, blah, blah, blah. And then I added an AI message as if the model has already replied, saying it's an action, forward input to positive feedback storage, and the reply, thank you very much, blah, 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 blah. And then I did the same for a negative example. I added the user message, I'm facing frequent crashes, and then the AI would have answered, open a new ticket, crash after update Android, and then we are so sorry to hear as a message to give back to the person that gave the feedback. And then I just added 2 more like one positive, one negative more. By the way, these are all created with ChatGPT. And then I'm going to ask my actual question without even telling the model what to do. I just gave it this example of how it would have behaved before. And then I ask it, how can your app be so slow? Please do something about it. Then let's have a look what it comes up with. So we just sent this memory along of how it should have behaved. And it answers action, open new ticket, app performance improvement, and then we apologize for the slow performance, and we understand the frustration, blah, 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 blah. So this is a nice way to steer a model. It's often more effective than telling it what it should do. It's just showing, look, this is what you've been doing. All right, now it gets really interesting. We have our AI services in LangChain4j, and they return plain Java objects. And this time, it's not a surprise anymore, because you've already seen some examples. So an AI service allows you to define an interface of what you want to happen. So it's an object, and you put all the methods you want to use there. And the way LangChain4j handles it is it looks a bit at the name of your methods, and then it looks at your input and especially output argument. So if it's called chat and you want a string back, it's going to know this is just model generate plain chatting with your model. And then, so we just define that there should be a method chat that takes a string and that returns a string. And when we build this like this, AI services.create from our assistant class, the interface we just defined, with this model, we also need our model that's set here. Then it will just make this available for us, and this will work right away. So we can chat with this thing without writing any more code around it. And then there's ways to take this to the next level. You can add a system message with annotations like this. So here we have a chef interface. So it's a cook, and we want us to actually, you are a professional chef, you're friendly, polite, and concise, and then the AI will know that it has to behave like that. And again, we just create the service, and there you go. So here are some examples of how you can set system messages. User messages, here's an example where we use actually variables inside. So we want a translator service that says, translate the following text, and text will then just be an argument when we call the method translate. This will just work like that. I'm not going to run them all, but so there's really cool stuff in here. Have a look. This example I showed already this morning, where you would extract an enum or a Boolean. And I would go scroll down until we have plain old Java objects here. So we can define, for example, a person with a first name, last name, birth date, and a toString method because we want to print it afterwards. And then we can, again, make such an AI service, a person extractor, with a method extract the person from, and then there's text. And the user message, to make sure AI knows what it has to do, is extract the information about a person from this text, from this variable. And the text we have is here in 1968, amidst the fading echoes of Independence Day, a child named John arrived under the calm evening sky. This newborn, bearing the surname Doe, marked the start of a new journey. So all we do is we create this AI service that we defined here, and then we run this, and it will extract our person. So yeah, just imagine what you can start doing, what kind of documents you can start categorizing, what kind of feedback you can start to handle here. So it got us back this Java object, the person with first name John, last name Doe, and this birth date. In here, there's also examples. Oh yeah, with descriptions, that's actually important. If it's not clear from the method name what it should do, you can add just a description. For example, you want a recipe with a title in 3 words maximum. You just add this to your description, and the model will know what to do with it. So there's not much coding involved anymore this way. Down here, we also have very interesting examples with chat memory added, and with a memory for each user. So if you're like building enterprise applications, you will want to remember the right thing per user. There's an example here, how that is done. And there's also an example afterwards with persistent memory, where you write stuff to your database. OK, let's start using tools. So depending on which model you use, they support this option to call tools when you define them for them. So we have here a calculator with some method string length, where it will determine how long the string is, an add method, and a square root method. And then we add this tool annotation to it, where it says what it does. And then we can pass these things to the model. So it will be able to call our Java code here when it thinks it needs it. We have a simple chat AI service here that just has this method that you can chat with it. We define our model. And then we're going to create this AI service. But what's new this time is we're going to add our tools from this calculator class. And we have a chat memory too. And what we will ask now, just to test, so it should know which methods it has available, which input arguments they need, if it has the input arguments, when it has to call them, and then it can call them, get the answer, and answer you based on that. So we ask it, what is the square root of the sum of the numbers of the letters in the words hello and world? Let me start running this, because this, of course, makes for a couple of more calls back and forth. So it will take a little longer. But depending on the time you run it, it will or will not use the number of characters method, because sometimes it just knows it's 5, and sometimes it still decides to call the tool. Yeah, it did actually call the string length method. I've printed this to console for you to see. So then it knows it got 2 times 5 out of that. Then it called the add method. It's funny, because I think it could do it, 5 plus 5. But anyway, it knew it had the method, so it called it. And then the square root. And then it gets all this information back. That's actually all behind the scenes, right? It's not printed out. The only thing we get to see, actually, when we're not putting this all on console, is this. The square root of the sum of the numbers of the letters in the word hello and world is approximately 3.162. And that should be correct, because it actually used mathematical tools for it. And that's really important, because LLMs are typically bad at math, but like very bad at math. So you want to give it these tools. It goes still a little crazier. Dynamic tools, in which case you can tell the model, you have tools available, but you have to be able to write the code yourself. And in this case, it's a JavaScript example, so the model knows I can use any tool that I'm able to write. And that's where this code execution tools come in, because we will then call them for you when you give it to the model. So we have this judge null tool. And then we build our AI service again, where we have the language model, a memory, and this judge null tool, so it knows. And then we're going to ask it, what's the square root of a huge number here? Capitalize every third letter in ABC, ABC. And what is the number of hours between something crazy that I do not want to start calculating myself? Now, to see if it makes sense to call a tool, I also ran this through the normal ChatGPT and asked it these questions to see if it could actually answer without tools. There was one thing it was able to do correctly. So let's see. Who thinks it's the first one that it had correct? The square root of the huge number? Nobody. Capitalize every third letter in ABC, ABC. OK, majority. And then this number of hours between these very hard dates. So through this, it did the square root correctly. And the other two, it failed. Even these capitalize every third letter. So let's see now if it knows that it can write tools, if it does any better. And this is such a meta feature, right? And I actually hope they will add it in ChatGPT at some point, like in the models themselves, because if they're capable to write the code, run the code, Why isn't it in there already? That would be so much smarter even. So it managed to successfully capitalize this. For sure, it's right. I've seen this example a couple of times. Yes, and this is also the right number of hours. So our job is pretty much done, right, as coders. OK, one extra thing we have, this is this retrieval augmented generation to make it stop hallucinating and to make it know what our company is about. We don't have all our documents plain on the internet, and we still want to know it to know what documents we actually have, what are terms of use, or like internally if people want to search in our documents. There is a way to do this rather than really starting to train a model on all this data. It's really hard, and you actually need a lot of data in order to get good results. There's a nicer way where we're gonna actually just tell the model, look, here are all our documents. This was the question. Now answer. But all our documents usually will not fit in this context window, so we will have to reduce what we put in there. And to know what we best put in there, we will need to find the segments that are relevant to our question. And that's the tricky point. How do we find which parts of our documents are relevant? And that's where we're going to use these embedding models that will, first we will split our documents in pieces, and then we will embed this meaning as a numeric vector, put this in these embedding store databases that are really good at afterwards retrieving it. And we also store our original segments together, so we can retrieve them entirely. So then when we bring it all together, we have a user that asks a question. Then there's the embedding model that's going to make a vector representation of this question. And it's important that it's the same embedding model, because they're not compatible. So with the same embedding model, you're going to embed the question. You'll know kind of the meaning of the question. You'll search a similar one, or all the similar parts in your embedding store. And then you will have a list of relevant segments that you'll put in the context window. You'll say, the user asked this, and you may find the information in here. And then the model, that's all that we send together to the language model, and it will figure it out. So brings us to our last example here. There's this if you need simplicity example where there's all kind of same defaults set for you and makes it really easy. Underneath, there's a more complicated example where you can set the segment length, if you want overlap, and everything. So let's just have a look at the simple model, the simple version, and then at home you can go wild with the more complex version. So we will need an embedding model to make these vectors for us. And the nice thing is, there's a lot of embedding models out there. There's a lot of them that we support very easily in LangChain4j, but we even have small embedding models that come as a dependency with it, and that just turn on your computer. So you don't even need access to the internet to make these vectors of meaning. I mean, it will eat your CPU a bit. Then we have an embedding store, and for this example, we take an in-memory one. But typically, you want to persist this, because typically, you want to embed all your documents once, or maybe once every time they're updated, and then leave them. You don't want to do this every time again when somebody asks a question, right? But for the demo, we have one in-memory, where we save all these vectors. And then we built an embedding store ingester. So we have a document splitter here, and we will use a segment size of 300 characters and no overlap. These are parameters that you have to play with. It depends a lot on what type of data you want to retrieve. So there's quite some optimization possible there. Then we give our embedding model and our embedding store, and then we have an ingester. Next step is we want to load our document. That's where all these file types we support come in, text, Word, GitHub, whatnot. And we're gonna ingest then a story about a happy carrot. We have it in our resources. It's a cute little story. Let me see if I can get that on the screen. Yes. And then we have our ingester is gonna ingest this document. Afterwards, we gonna retrieve this. We have a chat language model. It has nothing to do with embedding this question. It has everything to do with, at the end, making sense of the fragments and the original question. That's where the chat language model is going to work. And we will have a retriever to find the right parts. And we need to give this embedding model the same one, and this embedding store where all our vectors are. So it will know with this retriever, all right, we got the question, we're going to embed it, and we're going to find the similar segments in our embedding store. And then with this chain, we can simply use the method execute. And if we then ask, who is Charlie, which is not something GPT is typically trained on, it's going to really get this out of our document. So there's a new feature in 0.26 version of LangChain4j that's out since a week or so, and it's advanced rag. Because very often when you use the plain rag that we saw before, it will retrieve documents that are not relevant. And the problem is when you give an LLM something that's not relevant and you say, it might be relevant, right? Use it or use it not. It will always use it, and it will ruin your answer quite a bit. So advanced rag has some really nice things. First thing, query transformation. If you ask, if you're in a conversation with a large language model, you're talking about John Doe, and then somewhat later you ask, when was he born? If you just embed when was he born, you will never find the pieces about John Doe back. So first thing is to let a large language model, again, kind of summarize all the information into your question. And we turn it into something like birth date of John Doe. And then with that, you will have a bigger chance to find the relevant segments. Then you will route your questions, because models are smart enough to know that some questions are really about meaning, but other questions are maybe more about really querying your database. And it can write these queries. So it will pick the parts, and it will get you some parts from your database when it's relevant, and it will get you some parts of your vector store or embedding store when it's about semantic meaning. And then you put it all back together, and then very important, you will re-rank them. So you have a number of segments that seemed relevant, then you're gonna call in another LLM and say, are they really relevant? Before you pass them on for answering the real question. And then it will rank them, and then you can put a cutoff frequency and only keep the ones that are really relevant to your questions. And you get much, much better results, which is important for enterprise, for sure, that it's not too far off. Just to show you where our advanced rag examples are. Yes, they're here. So in these examples, we have naive rag, which is the first one we saw, which we looked into details, and then this advanced rag. So query compression, making your query better, query routing, get it from the right source and not just all mixed. The re-ranking is cleaning up the parts you found. And then with metadata, that's actually an important concept. We have on our segments, we have metadata that we will not use to make a vector out of it. So it's not really, it's things like your document title or the URL there, or anything that you do not want to embed in your vector because it is like nonsense semantically, but you still want it to be returned to your user, for example. Then that goes in the metadata. And sometimes you just want to filter on that, like just everything that has a URL starting with this or that. And so that's also added here. So you can have a look at that if you want to build that type of applications. OK, so rag, it's really super nice, but it's also quite hard, I must say, to really get it working well. So advanced rag is a big step forward. If you're prototyping this, use these in-process embedding models and in-memory embedding stores just to get a fast prototype up where you can start playing with these segments overlaps and segment sizes and what to encode and what to not put in your vector. So it needs a couple of rounds of iteration to get this working well. It really depends on your type of documents. Clean up your documents if appropriate, and then try these advanced rag techniques if you want better quality, but the latency will go up because there's just more calls to LLMs. But then again, in future, the latency will go down again. So let's see where we end with that. Right, our framework integrations with a meme that's totally unrelated, but I liked it. So we already saw this Spring Boot example at the beginning, and I would happily also show you a Quarkus example. That would be here. Let me go to my terminal. I'm there already. Okay, let's give this a minute to get up and running. I'm already sharing you the useful links. So on our repository, we have the README that links you to our documentation, to our examples, where you find this tutorial section. That's kind of the walkthrough of what I did today. There's this reg example specifically. There's one in Spring Boot. There's one in Quarkus. I'm going to let you take the pictures. And see, this might be up. Yes, so this is the Quarkus example where you can write your reviews about financial products. I mean, my banking app is horribly slow. And then it should tell me, we apologize for the inconvenience. Our team will contact you to address the issue. But what I wanted to show specifically about this Quarkus example is that they have a great dev UI, which is very interesting. They have here this LangChain4j experimental part. Yes, and it allows you to chat, for example. You can put the system message. You're talking to a toddler. I guess if you want to play around a bit, it's really useful. And it's using this model that you configured. Does Santa Claus exist? Let's see. It's actually the first time I let my kids talk to ChatGPT, this is what they asked. Yes, Santa Claus is a fun and magical character that many people believe in. He brings gifts to children on Christmas Eve. Yeah. So anyway, you can play around with your model here, and there's much features upcoming, I believe, to make this even more interesting, to really tweak your application. Right. So that was our repository. Here are these leaderboards that I talked about. If you want to have different models, commercial or open source, ranked in their performance. Do be aware that if you want to turn a local model, they're easily 40 gigabytes of GPU that you will need, so you need a beefy machine somewhere, and they can be quite costly. And then they will also likely use all your GPU. So yeah, local models on local hardware, that's a whole quest on itself. A hallucination leaderboard, because yeah, if you want something that's a bit more deterministic, you might want to go and have a look there. And then there's some interesting local communities, info on embedding models, on RAG, retrieval augmented generation, and then some short courses on LLM that's really worth taking. Also, just have a little look into prompt engineering before you end up crying, why doesn't it do what I want? Is really, some people figured out some really nice tricks already. Good. So I hope you like this, and I hope you have plenty of ideas for your own integrations. So we look forward to your pull requests. Yeah, enjoy. And we're really happy to hear your feedback, your contributions, and what you want to do with this. Also, what you miss still in the framework. It really helps us steering our development efforts. Thank you very much for your attention.